Welcome pre-cal students to class today on this Tuesday the 25th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's go ahead and get started with some announcements. There will be a quiz this Saturday. It will be due Tuesday, and so make sure you're ready for that. I will email that to you Friday night or Saturday morning. Your tests that you took yesterday in class are due Wednesday. So please make sure you have all of your questions asked, the test completely done by Wednesday. And by the way, remember, if you're going to come over, I've got to know 1 day in advance, okay? 1 day in advance. And then integrity sheets. Make sure your integrity sheets are completely caught up. Never get behind on those, guys. Very, very important to stay on top of those. And those are the announcements. Grab your notebooks and pens and pencils. Let's get started right away. Okay, men, let's continue our study into lines and their slopes. We've been doing a lot of studying on lines and slopes, so let's continue that study. Today we are going to see how slopes and parallel perpendicular lines relate to each other. We are also going to look at some more word problems today, which I know gets you guys very excited about that, word problems. Let's see. Your heading today is parallel and perpendicular lines. The lesson number is 1.4, and the date today, if you'd like to keep track of that, that's way too big. Let's fix that real quick. The date today is the 25th. The 25th. All right, and you know me, I go fast. Pause the video as much as you need to copy things down. Your heading today is parallel and perpendicular lines, and the date today is 25th, lesson 1.4. Let's start off with 2. I do know how to spell the word 2. That's very funny, isn't it? I'll have to fix that later. Let's start off with 2 very important statements. Okay? 2 very important statements. Statement number 1. Parallel lines will always have, wow, I'm on a streak here, aren't I? Will always have identical. I wish Mimeopad had spell check. It does not, so I get typing fast and I don't catch my typos. But I do know how to spell this word. Parallel lines have identical slopes. Parallel lines have identical slopes. Please write that down. And now I want to draw your attention to this example right here. You might want to copy this in your notes or not. That's totally up to you. But doesn't it make sense? I'm trying to give you a picture here. Does it not make sense that parallel lines would have the same slope? I mean, first of all, if they're parallel, they're going to be sloping the same way. So notice both of these slopes are negative. If they would have both been going this way, like this, then they both would have been positive. And then think about the rise over run. If you have a triangle here that touches here, I mean, your rise is going to be the same as this one right here, and your run, they're going to be identical, guys. It just makes sense. Go ahead and count the rise. 1, 2, 3. Count the rise over here. 1, 2, 3. Count the run. 1, 2, 3, 4. Count the run. 1, 2, 3, 4. The rise over run is 3 over 4 for both of these, negative 3/4. So the slope for this line is negative 3/4. The slope for this line is negative 3/4. Let me say it again. If 2 lines are parallel, they will have identical slopes. You need to know that. Very important statement number 2. Perpendicular lines have negative inverse slopes. Perpendicular lines have negative inverse slopes. Let me give you an example of what I mean. Let's say that line number 1 had a slope of negative 3/2. Then if line number 2 is perpendicular to line number 1, do you know what the slope of line number 2 would be? You change the sign, so here it's negative, this would be positive, and you flip the fraction, 2/3. So there we go. So if these 2 lines are perpendicular, one slope will be negative, one slope will be positive, and one slope will be the inverse, or flipped if you want to use that word. One slope will be the inverse of the other slope. So let me go over here and show this to you. Okay, watch this carefully, please. Let's go ahead. These 2 lines here are perpendicular. They have a right angle right here. They're totally perpendicular. Okay, so with that in mind, let's find the slope of this one line right here. So the slope of this line here, my rise would be 1, 2, 3, 4, 5. So I have a rise of 5. My run would be 1, 2, 3, 4. So my slope is rise over run, 5/4. The line is sloping upwards, so positive 5/4. Now, let's see what the slope of this line is. Let's go ahead and draw our triangle here. Let's find our rise starting here. 1, 2, 3, 4. So your rise is 4. Let's find your run starting here. 1, 2, 3, 4, 5. Your run is 5. So the slope of this line, of course, M means slope. The slope of this line right here would be rise over run, and it's negative because the line is sloping downward from left to right. Negative 4/5. Look, it works. This slope is positive, this slope is negative. This one is 5/4, this one is 4/5. Or you could say this slope is negative, this one's positive, this slope is 4/5, so this slope is 5/4. Whenever two lines, let me get a drink real quick. I have had this thing now for about a month, I just cannot shake it. Whenever two lines are truly perpendicular, their slopes will have opposite signs. That's why we use the word negative. Negative means change the sign, and they will be inverse of each other. So with that in mind, let's go ahead and do 3 quick problems over here. Copy this down. Determine whether the following pairs of lines, determine whether each one is parallel, perpendicular, or neither. Okay, let's take our first equation. How in the world can I find the slope of this equation? Well, I taught you guys this last week. Get y by itself, and once y is by itself, you know two things. You know what the slope is and the y-intercept. So I bring this 2 over, I make it a -2, and now the number with x is your slope. So the slope of this line is 5. Now let's find the slope of this line. Remember how to do it? We're going to get y by itself. So we're going to bring x over and make it a -x. So I would have 5y equals, bring your x over and make it a -x. And you already have a -15 on this side, so -15. And now divide everything by 5. Divide this term by 5. There's a -1 in front of the x. Divide by 5, you get -1/5. Divide this by 5, and you get -3. Now, what number is with the x? -1/5. So your slope is -1/5. Okay, so we know the slope of this linear equation is 5. We know the slope of this linear equation is -1/5. Let's see if these two lines are parallel. Parallel lines have the same slope. Are these two slopes identical? No. So we know these two lines are not parallel. Well, let's see if they're perpendicular. We know perpendicular slopes, first of all, will have different signs. Well, this slope is positive, this slope is negative, so far so good. We also know they will be inverses of each other. Well, 5 is the same thing as 5 over what? 1. So 5 over 1 inverted is 1/5. Or you could say 1/5 inverted is 5 over 1. So are these two slopes, do they have opposite signs? Yes. Are they inverses of each other? Yes. So you know for a fact that these two lines right here, if you were to graph them, you would see they are what? Perpendicular. All right, let's try another one. Again, I go fast. You got to back it up and listen to it, and that's fine. But like I've always said, you can always slow me down, but you can't speed me up, so I go fast on purpose. Okay, let's try the same thing on these two equations. So let's take this equation right here, and let's get y by itself. So 2y equals, bring your positive 4x over and make it negative. There's already a positive 8 over here, so positive 8. And now divide everything by 2. So 2y divided by 2 is y, negative 4x divided by 2 is negative 2x, and 8 divided by 2 is 4. So we did all of our work. Here's our slope. M equals -2. Now let's find the slope. Put a little dividing line here. Now let's find the slope of this equation right here. Alright, let's get y by itself. And to be honest with you, I always like the y to be on the left side. You don't have to do it that way. For me, it's just consistent. So I'm going to bring the negative y over and make it a positive y. When I do that, I'm going to bring the 2x over and the 5 over and change their sign. So when I bring the 2x over, it becomes a negative 2x. When I bring the positive 5 over, it becomes a negative 5. And look at that, y is already by itself, so the slope would be negative 2. Well, look at that. The two slopes are identical. They are identical. So I know for a fact that these two linear equations, if you were to graph their lines, you would see those two lines will be parallel. One more and we'll go on to something else. And if you feel like you don't need this example, that's up to you. You're welcome to skip it and go on. That's up to you. If you want to try it on your own and just get some practice on your own, that's fine. I'm going to move over here, get a little more space to work with, but all of that is up to you. Okay, I'm going to find the slope of this first line, and it looks like y is already taken care of. I mean, I know I like y to be on the left side, but when y is already by itself, I'm just going to leave it alone. So y equals 2x plus 1. Now, what number is with the x? 2. Notice y is all by itself, so there's no work to do. The number beside the x, or the coefficient of the x, is 2. So you know your slope is 2. Now let's come over here. Let's get y by itself. We're going to bring the 3x over and make it a negative 3x. So negative 3x, there's already a positive 4 here, positive 4. Okay, y is all by itself, so I know the slope is always the coefficient of the x, and in this case the coefficient of the x is negative 3. Are these two slopes identical? No. Are they negative inverses of each other? No, not at all. I mean, if you have 2 over 1 and you flip it, you get 1/2, not 3. So no, these two slopes are not equivalent, and they're not negative inverses of each other. So then I know for a fact that if you were to graph these two lines right here, they would be neither parallel, that's the symbol for parallel, or perpendicular, and that's the symbol for perpendicular. So those two lines would be neither one. Okay? All right, hope that helps. Let's continue on to another example. Now, look what the directions say. Write equations of lines that are A, parallel, and B, perpendicular to the, well, I'm having a really bad spelling day, to the graph of the line 4y minus x equals 20. Okay? 4y minus x equals 20, and containing the point 2, negative 3. Now, just listen. Let me teach you how to do this. It's not that hard, okay? Just listen. Now, right away, we see that we're going to write equations of lines, and we have two problems. We have part A, that would be a parallel line, and part B. So, let's just divide the page up into two sections. We have two problems. Now, anytime I write a linear equation, I taught you this last week. Let's see how well you remember. Anytime you need to write a linear equation, there are two things you need. You need to know the slope, which M represents slope, and you need the y-intercept, and B represents the y-intercept. So we know for both of these problems we have to have the slope and we have to have the y-intercept. And we have none of this. So we got our work cut out for us. Okay, let's go ahead and start with problem A. I want you to write the equation of a line that's parallel to this line. Parallel to this line. Now hold it. If I want a line that's parallel to this line right here, then what do I know? I know their slopes are going to be the same. So hey, I just had a thought. If I could find the slope of this line, and the two lines are parallel, and I can find the slope of this line, then that would be the exact same slope I would need right here. Because whenever two lines are parallel, then they have the same slope. So I'm going to take this equation right here, 4y minus x equals 20, and I'm going to very quickly find the slope of this line. I'm going to bring the x over and make it positive. Then I'm going to divide everything by 4. Don't forget there's a 1 in front of the x, so 1 divided by 4, 1/4. And then 20 divided by 4 is 5. So I did it. What is the slope of this line? Does everybody see it? 1/4. And the line I'm trying to find, the linear equation I'm trying to find, is parallel to this line. So if the slope of this line is 1/4, then the slope of the line I'm looking for is also 1/4, because these two lines are supposed to be parallel. Makes sense to me. Now I'm going to pull this over here for a reason. Just trust me. We're going to use this later in a second, okay, over here. But hopefully you saw what I just did. If not, rewind the video and watch again. Let me get a drink here. Whenever two lines are parallel, they have the same slope. So I found the slope of this line, and then I know that the line I'm looking for is parallel to this line right here. So they have the same slope. So I found the slope of this line, and then I knew the slope would be 1/4. Now I've got to find the y-intercept. Well, remember, I know a couple more things about this line. I know the slope now, and I also know that it passes through this point. Where did I get that from? Right here. The equation of the line parallel to this line and containing the point or passing through the point to -3. So if I know a point and I know the slope and I'm trying to find b, do y'all remember the formula you're supposed to use? I hope you do. Y equals mx plus b. So for y, I'm going to put -3. For m, I'm going to put 1/4. For x, I'm going to substitute 2 plus b. Now let's solve for b. First of all, I can simplify the right side of the equation. 1/4 times 2 is 1/2 plus b. And now bring the 1/2 over and make it negative, and you end up with -3.5 equals b. If you want to use -7/2, that's totally acceptable. I have no problem with that. So now I know what b is, -7/2. So I know what the slope is. I know what the y-intercept is. So write your linear equation and you're done. Here's your answer. Y equals your slope 1/4 always goes next to the x, and then your constant term goes at the end, -7/2 or -3.5. Okay, so there. We wrote the equation of a line that's parallel to a given line. Now let's try to work out problem number 2 over here. All right, problem number 2, or letter B. Now watch this. The reason I pulled this work over is there's no need to find the slope of this line again. We already did it over here, and remember I pulled the work over here and put it over here. So we already know the slope of this line is what? 1/4, and we found that right here. Okay, so let's not worry about that. That's already taken care of. Now I'm trying to, let's cross this off. We're on part B. I'm trying to write the equation of a line that's perpendicular to this line and passes through the point to -3. Okay, so the line I'm trying to find is perpendicular to this line. Well, what's the slope of this line? 1/4. So if the slope of this line is 1/4, what's the negative inverse? Well, first of all, you change the sign. This is a positive 1/4, so I'm going to put a negative sign. And then if you flip 1/4, you get 4/1, or just 4. So just like that, I found the slope. So if I know the slope and I know a point the line passes through, I can find b relatively quickly by using my formula, y equals mx plus b. So where the y is, I will substitute a -3. Where the m is, I will substitute -4. Where the x is, I will substitute 2. And now we can simplify this right side over here. So -3 equals -8, positive b. Now bring the -8 over and make a positive 8. And when you do that, you will be left with 5 equals b. 5 equals b. So it looks like to me I know the slope, I know the y-intercept, so I'm ready to write my linear equation. Y equals -4x plus or positive 5. There you go. We did it. Not too bad. But you're learning to apply all of this slope information and parallel and perpendicular line information into problems. Okay? One more problem, I believe, and then we're finished for the class period. Turn your books to page 112. You might have to pause the video if you don't have your book close by. I'm turning there now as I talk, page 112, number 9. And if you'll read that problem, it reads something like this. Model the data in the table on truck sales on the previous page with a linear function. So when they say model, they mean write a linear equation. So they're asking us to model with a linear equation the truck information on the previous page. After you write the model, please look at the rest of the problem. The problem then says, predict the number of trucks that will be sold in 2010. Okay? Now, what I did is I went ahead and put the previous page up here for you. If you'll turn back in your books to page 111, you'll see the previous model they're talking about. And that top chart says number of trucks sold in millions. Okay? So the year 2000 refers to the number 0. The year 2001 refers to the number 1. The year 2002 refers to the number 2. In other words, let me put this in really simple English for you. You have ordered pairs. Your ordered pairs would be 0, 2.15, 1, 2.32, 2, 2.27, 3, 2.36. Do you see where I'm getting these ordered pairs? 0, 2.15, 1, 2.32. And what they did is they plotted those points right over here for you. I'm going to make this a little bigger. I'm not so sure it's easy for you guys to see. And so they plotted those points for you right here. Now they're asking you, now listen, they're asking you to write a linear model or a linear equation. And usually when you write a linear equation, you have points that line up in a perfect line, like this. And you have a line, and you simply write the linear equation. You could pick this point here and this point here, find the slope, and go on your way. Okay? But in this problem here, notice how the points don't exactly line up in a straight line. So here's what they want you to do. Would you please turn back to page 112? Please turn back to page 112. Look in the middle of the page. Do you see how they've drawn a line just kind of right smack dab? Let me change color here. They've drawn a line right smack dab through the middle. And I'm not drawing a very good line here, but they're drawing a line just kind of right smack dab through the middle. Do you see that? And what they want you to do is they just want you to pick 2 points. Any 2 points, Mr. Earhart? Yeah, for the most part, but I mean, when you draw a line through the middle, usually it helps to pick a point near the beginning and kind of near the end that's close to the line. Like this point here is a good distance above the line compared to the other points. It's okay to use that point, but really you want to try to pick points that one somewhere near the beginning and one somewhere near the end that are close to the line. So I would probably choose this point and this point here. Let's see what the book chose. If you'll look, I think they actually chose those points. I didn't do that on purpose, but if you'll look on page 212, if you'll look at the 4th line down, you'll see this word. Look at the 4th line down, you'll see the word solution. Do you see that okay? And then you'll see the 2 points they picked. It says let's use 0, 2.15 and 5, 2.50. So there we go. You say, well, Mr. Earhart, what does that do? Well, guys, you should know, if we're going to write a linear model, what 2 things do we need? We need the slope and we need the y-intercept, correct? Don't we need those 2 things? Well, students, listen to me. We already know the y-intercept. Look at the graph. There it is. Remember, the ordered pair is what? 0, 2.15. I mean, this is the y-axis. This is the x-axis right here. You know your y-intercept. So there's no work to do on that. I hope you understand that. There's no work to be shown. There we go. Now we got to find the slope. And if you'll look in your book, they did it for you in red. It says m equals, and they have y minus y over x minus x. 2.50 minus 2.15 over 5 minus 0. They're just using this formula right here. We learned this about a week ago. Y minus y over x minus x. This should be reviewed from Algebra 2. So if you do that correctly, you will get this right here. Okay? So now that you know the slope and now that you know the y-intercept, we can go ahead and write a linear equation. That gives us a linear model of the number of trucks that have been sold. Okay? So there we go. We have a linear model. And that's what they said to do. Now there's one more thing we have to do still. Remember, the last sentence said predict the number of trucks that will be sold in 2010 using your model. Okay, well, let's go back to this graph. The year 2000 meant you put what in for X? 0. The year 2001 meant you put 1 in. The year 2002 meant that you put 2 in. So what number do you think you put in for X for the year 2010? Wouldn't you put 10 in for X? Sure you would. So let's come back over here, and now we're simply going to substitute 10 in for X, which is the same thing as saying the year 2010, and we're going to estimate using this model or predict approximately how many cars will sell in 2010. And they've done the work for you there in the book. If you look down toward the bottom of the page, you will see they've substituted 10 in for X, and you get this answer out right here, 2.85. Don't forget it's in millions, so you got to put the word million. But the predicted number of truck sales in the year 2010 will be 2.85 million. There we go. We found the linear equation, and we predicted how many vehicles would be sold in 2010. So do you see how important it is to get a nice model like this? As long as your points are kind of lining up in a straight line, you can estimate a linear equation and then estimate the future that will kind of help you with your sales. All right, let me say one more thing. If you will look over one page to page 113, you will see there's a way to use your calculator to find a regression line. And what that does for you is it takes all of these ordered pairs right here that we talked about, and there's a formula called the least squares regression line formula, and it's a really, really hard, difficult formula to use, but your calculator does it for you. And if you'll look at the top of page 113, I apologize for not having this in the video where you can see it, but if you'll look at the top of page 113 to the left, the first yellow box, there's 5 yellow boxes going down the left side. Well, the top yellow box shows the ordered pairs: 0, 2.15, 1, 2.32, 2, 2.27, and you would enter those 5 ordered pairs, and then you go to a certain list and you go to option 4 there. Look at the third yellow box down. Option 4 says linear regression AX plus B. Anyways, I would like to get into this later, so Lord willing, if we have time when this chapter is over, I'm going to come back to this because I really feel like it's important for you guys to know how to do a least squares regression line. Okay, but that's it for today. I hope that you've understood this. Call or email if you have any questions at all. This is, let's see, 14.7, not too bad. 8 problems here and 6 here for a total of 14. And so 6 word problems and 8 of the other problems. So it shouldn't be too bad. Work on this diligently. Watch the help video if you need to. And if you have any questions, don't hesitate to call or email. Have a good day.